Okay, this is Unit 4. We are going to go through one example of each topic. And this video, I'm not really sure what the length is going to be. We're going to just go until I run out of time. And yeah, I guess we'll start on topic 1. So I've got topic 1 and topic 2 on the same slide here um, because topic 1 goes pretty quick and topic 2 goes pretty quick. So I put them all together on one slide for us to start. So looking at topic 1, the left-hand side here, we're trying to find the degree and the leading coefficient of this polynomial. This polynomial has 4 terms in it. That's basically what a polynomial is. It's poly meaning many and nomial meaning terms. We've got 4 terms, and these terms technically are out of order. So, for example, if I look at the exponents, this one has an exponent of 5, this one has an exponent of 8, that one has an exponent of 1, and that one doesn't even have a variable attached to it, so they should go in a different order. I'm going to order those first before we get into what I'm talking about next, but it should look like this. We have 2v to the 8th plus 5v to the 5th plus 7v minus 18. That's the way it should look, because when we want to order our polynomials with the highest exponent in front. Then basically that's what this question is asking us. It's asking for the degree. The degree of this polynomial is going to be 8 because that's our highest exponent that I can see. The leading coefficient is the number in front of the variable with the highest exponent. So what I'm looking at right here is that 2. That's in front when I order it, so that would be my leading coefficient. My leading coefficient would be 2. That's it for topic number 1. Topic number 2. I see that I'm subtracting these groups of polynomials, so I'm subtracting these polynomials that are in parentheses. It might ask you to add them as well. I wanted to do the subtraction problem because it's a little bit more difficult, because we have to remember that we're actually subtracting all of this stuff. So all of that stuff is going to get minused, meaning, or subtracted, meaning I'm basically going to be distributing this negative in to all of these parts to start the problem. So if I distribute that negative, what I'm going to be left with here, I'm going to change this into a positive because it's no longer there. That negative is distributed. And this would become a positive since it was a negative. This one here is going to become a negative because it was positive. And this one here is going to become a negative as well because it was positive to start. At that point, once you have the plus sign in the middle, the parentheses are basically useless. There's no need for them anymore. So what we have, we can combine like terms here. I'm going to combine the 5u squared and the 3u squared, so it would be an 8u squared. This is a negative 2u and a positive, oh, nope, I'm sorry, we changed it to a negative. So it's a negative 2u and a negative 4u, which would make it a negative 6u. And then the last part there, we have a positive 1 and a positive 6. That would, oh, I almost made that mistake again. See, obviously it's kind of tricky. You can make mistakes on it pretty easily. That's actually a negative 6. We changed it to a negative 6. So this would become a negative 5 when I added it to the 1. Okay, that's it for topic number 2. Let's go on to topic number 3. Here's topic number 3. We are basically going to, it says rewrite without the parentheses, but to do that, we have to multiply these two. There's a multiplication symbol between two sets of parentheses if you don't see it. Now, what am I multiplying? I'm multiplying terms. How many terms are we seeing here? Well, I'm seeing one term there, and I'm also seeing one term there. And then I see one term over here. How do I know that these are terms? Well, addition and subtraction symbols are the things that separate terms. So if I'm going to multiply these two parentheses together, basically I'm going to take this term and I'm going to distribute it here. Then I'm going to take it and I'm going to distribute it there as well. So I should be doing two sets of multiplications to solve this question. So let's take the first two, the first group of parentheses that I did, those right there. If I multiply the numbers, I'll have negative 12. If I multiply the variables, I have c to the 4th and c, which would make c to the 5th if I multiplied those. And then d to the 5th and d to the 6th would make d to the 11th if I multiplied them. Okay, and I'm going to distribute to the other one now. So I'll have a positive 18 with the numbers, c to the 3rd when I multiply those c's, And then d to the 6th gets to just hang out. We didn't have a d to multiply over here, so we're just going to carry it along. Actually, this is our final answer of the problem as well. So that's what you would type into Alex for that one. Number 4. It says multiply. We have 4x minus 3 and 6x minus 1. This is going to get into foiling, which hopefully we've heard of before. If I FOIL, that means I'm going to multiply the first terms, the outside terms, the inside terms, and then the last terms. So let's multiply the first terms here. These would be my first terms, 4x and 6x. If I multiply those, I would get 24x squared. Okay, my outside terms would be these. So that would be a 4x and a negative 1, which would make a negative 4x. My inside terms are right here. We have a negative 3 times 6x, which would be a negative 18x. And then I'm going to multiply my last terms, which would be a negative 3 and a negative 1, and that would make a positive 3. I'm not completely done yet because I can still simplify those two middle terms there. So I can rewrite my 24x squared, and then negative 4x and negative 18x makes a negative 22x plus 3 will just hang out. Okay, let's go on to topic number 5. Here we go, topic number 5. This is the same idea. We're still going to FOIL. So when I multiply the first terms, I will have y squared. When I multiply my outside terms are here. I just want to keep in mind on this problem that I'm going to soon be multiplying the inside terms as well, because when I multiply the outside terms, I get a negative 6y. When I multiply the inside terms, I get a positive 6y. So basically, once I add those together and combine like terms, there's a lot of stuff that I'm doing in my head here, but I'm going to cancel those out, which means I will just be stuck with my last terms now. So my last terms when I multiply will be this. So you could go through number 5 just like we did on number 4. I would go back to topic number 4 if you're just watching number 5 for the first time. But those topics are basically the exact same, except I was able to skip a step on this one because I knew my middle two terms were going to cancel out when I added them together. Topic number 6. There's a big problem that comes from topic number 6 that a lot of people are doing, and if you're watching this video, maybe that's the reason why you're watching this video, because you're doing this issue. You're having this issue as well. We cannot just distribute this 2 into our parenthesis and get v squared plus 16. This is actually not the correct answer, but it's a common answer that a lot of people put on their tests and quizzes and stuff. Instead, we have to think about this like foiling, where we're going to expand this to v plus 4 times v plus 4. And now when I FOIL this out, because again, this is v plus 4 squared, I will have v squared. My outside terms and my inside terms would be 4v and 4v, which would make an 8v. And my last terms would be 16. So this is the correct answer. What this one up here was missing was those two middle terms. That's why that one doesn't work. This would be your correct answer. Topic number 7. All right, on topic number 7, I am going to be distributing 2 terms into 3 terms. Now, you could distribute these 3 terms into the 2 terms, but I just like the way that this one looks when I distribute this way. If I distribute the 7y, I'm going to distribute into this, and this, and this. Also, this 2 will need to be distributed into that, and into that. So we will have 6 things going on here. I'm going to start with the 7y, and I'm going to multiply that by everything first. So if I multiply the 7y in, I will get 42y to the 3rd power. I will get negative 21y squared. And then I will get, for the final piece, I will get a negative 35y. For the other part, I should have done this in the other color. Oh well, I'm just going to keep going. For distributing the 2 in, I will get, and I'm going to stack these up so that they have the same exponents on top of them. But 2 times 6y squared is 12y squared. I'm going to put it right here because it's under that other y squared that we already found. Negative 3y times 2 is negative 6y. And then negative 5 times 2 is a negative 10. So then we'll have 42y to the third power. We will have a negative 9y squared. We will have a negative 41y and a negative 10 after I simplified and combined all those like terms. So this is my final answer. We can move on to topic 8. Okay, topic 8. We are going to begin by dividing polynomials now. And this one is a lot easier than the next ones to come on topics 9 and 10 because it works out pretty perfectly for us. So I can actually divide both parts of the top here by the same denominator. So when I do that, when I'm dividing, 20 over 4 simplifies to 5. The x to the 6th power over x to the 2nd power, we subtract those when you divide with common bases. So we'd get x to the 4th minus, and then 28 divided by 4 is 7. And then x to the 5th over x to the 2nd would be x to the 3rd. And we are done. So that's the simple way of dividing polynomials. We divided both of those. So that's it. Topic number 9. This is the first time you may have ever seen this problem before, so it makes sense if you're watching this clip in the video. But topic number 9, we are going to divide polynomials. And this is going to be long division to be able to solve this. So the setup to this, you're going to create a box and you're going to put your 4x squared plus 35x plus 53 in the box. And then outside of the box, this is what we are dividing, x plus 7. So that's where we're starting. Okay. Now I'm going to look into this this area here to see how I can divide things. And I got to be very particular about what I'm looking for. So basically, I'm trying to figure out how many times does x go into 4x squared to start. Okay, so let me get back on my pen. I think x goes into 4x squared. This is kind of hard to explain. Maybe I can explain it a different way. X times what equals 4x squared? That's probably the correct way to explain it. X times something gives me 4x squared. So if I think about it over on the side here, x times blank equals 4x squared. Well, you would need a 4 for sure, and you would also need an x, right? That's what you need to be able to get 4x squared. So basically, this is the missing piece. That's what we need up here. So 4x squared divided by x equals 4x. Now notice I haven't done anything with the 7 yet. That's okay. We don't really need to worry about this last part. We just need to worry about the first letter. That 7 will come into play at the end. So now we can actually use that 7. We're going to multiply. This is long division. If you're struggling with long division, you'll need to maybe we'll find a YouTube video on that, just long division in general. But I'm going to multiply this 4x times both of those pieces. So 4x times x, we already said was 4x squared. That was the whole point. Do we want it to be the same as that one? 4x times 7 is 28x. So that 28x can go there. Now at this point, we can draw our subtraction line. I'm going to erase the scratch work. And we can subtract. So 4x squared minus 4x squared obviously goes away. Those would cancel out. And then I will be just be left with a 7x basically. Okay, so my next question is, how many times does this x go into 7x? Or basically, x times what equals 7x? Well, we're looking for that 7. So I can put a 7 up top. That piece right here is the important piece. And it's a positive 7, so I'll put a plus 7. And then I got to multiply that 7 through all of this stuff again. Oh, I also forgot this 53 is going to come down as well. But that's just a part of our old question. So now, when I multiply that 7 through, I'll have 7x. 7 times x is 7x. And then 7 times 7, so I'm taking again, if you're lost, I'm taking this 7 and I'm multiplying it by these pieces now. So I already multiplied it by the x. I'm going to multiply it by the 7 now. So 7 times 7 is 49. So that 49 would go there. Oops, not plus. That's going to be a minus. We always subtract. And then 7x's would cancel out. When I subtract 53 minus 49, I get a 4. So basically, this one will have a remainder of 4 because we have nothing else left. So our answer on this is right there. I understand that this isn't a perfect explanation. I will be doing one more of these on the next page. So if you want to follow that one might help you out even more because it'll be another example of it. Okay, topic number 10. If you did not watch topic number 9, watch that one first. But basically, this is the same thing. So I'm going to set it up with 8x to the third plus 14x squared plus 7x plus 13. Okay, and we'll have 2x plus 3 outside of those parentheses, or outside of the division symbol. Okay, so first step, we got to figure out how many times does 2x go into 8x to the third, or basically 2x times what gives me 8x to the third. I know that that's going to be a 4x squared, because when I take it and I multiply it back in, remember I always do that after I put it up top, I multiply it back into these. When I multiply it back into that highlighted spot, it's going to be 8x to the third. And then when I multiply the 4x squared with the 3, I will get 12x 12x to the second. Yeah. Okay. Then I'm going to subtract those. So I'll get nothing in the first part. I'll get a 2x squared here. And then I can bring everything else down. So I'll get a 7x and a 13. I'll bring those down. Next, I got to figure out the 2x. How many times does it go into 2x squared? Well, I know it's just going to be an x that's needed to multiply there. So when I multiply the x with all of the highlighted stuff, I will get 2x squared plus 3x. Again, I'm going to subtract. So I'll get nothing in the first part. I'll get 4x there, and the 13 is going to come down right there. Then I got to figure out how many times 2x goes into 4x. Well, 2x goes into 4x exactly 2 times. So 2 times 2x is 4x, and then 2 times 3 is 6. When I subtract those, I will get 7 left as my remainder. So that should be your answer to this question. All right, I think this is a good time to stop because now we are getting into factoring. So thank you for watching.